Okay, good evening everybody. I think we are now live. I apologize for my tardiness this evening. I've had all kinds of technical problems tonight with startup and setup, and so it's been quite a frustrating last half hour or so. I think everything is working at the moment. Not sure how long that's going to last, but we'll see. We'll see what happens. Okay, so let me get that off and go to planetarium software here, where we should be somewhere in there, I think. Okay, now what do I need here? Here's the camera. Okay, I had a heck of a time trying to get flats tonight. I'm not sure what the problem was, but something in SharpCap would not let me get a histogram peak. So let's go and put ourselves on Sirius, which is the major star in Canis Major, and let's make sure I can at least see something here. And it looks like we're fairly well aligned. Okay, 300. Make sure all this stuff is right. Just been a really frustrating last half hour or so, as nearly everything that could go wrong went wrong during my setup. So, in fact, it's a miracle I'm here only a few minutes late. Okay, so I think that's about right. Okay, so on with the show. Tonight, what we are going to be doing is looking at Canis Major. The biggest, brightest constellation in the winter sky is always Orion. Orion has just so many big, spectacular things in it that's what a lot of people spend time on. We may even finish off with some of the big, spectacular things up here, but something that's often overlooked is his faithful hunting dog here, Canis Major, and some of the neat things that are around here. There's quite a lot, as you can see in here. All these little yellow dotted circles are open star clusters, and the things with green have nebulosity in them. And the little red circles are my galaxies. And so I wonder if my sound sounds like my sound is maybe blasting out a little bit there. Anyway, this is a galaxy, and this is a galaxy. So there's just a lot of really neat things to see in the area of Sirius Major, Canis Major. So, including Sirius itself, which is the second brightest star in our sky, second only to our sun. So in the nighttime sky, it's actually the brightest star that we can see. So, yeah, that's what we're going to be looking at tonight. And Jim asked the question, "Hi Mike, can you talk a little bit about setting up for YouTube broadcast?" Well, tonight that would involve a lot of cuss words, Jim, so I'm not sure that would be the best thing. But yes, I can definitely tell you about some of that. Basically, YouTube makes it pretty easy to get set up for a broadcast account. You can just sign up, and then they'll send you a stream key, and I think they make you wait 24 hours to be able to use it, just so people aren't spamming their site with a bunch of stuff. And then the software that I actually use is here. The software is called Open Broadcaster Studio, and it's right now it's showing what's going on my screen, so you can't really see it very clearly, but it's called OBS, and it's what I use to actually do the broadcasting. It collects the signals from both audio and the video from my desktop, and combines it and puts it out to basically you put the YouTube stream key in there, and then it broadcasts it out to YouTube itself. So it works pretty well. It's open source software, and it works pretty well. And there is a learning curve to it. I would suggest going and downloading OBS and looking at its manuals. Its manual, which is fairly extensive, and obviously to broadcasting there's a lot of stuff involved, and I know just the tip of the iceberg that's enough to allow me to be able to do my little live streams, and that's it. So there's a lot more to it, but But that's the basic nuts and bolts of what I do, is just use OBS that then goes right into the YouTube live stream using the YouTube live stream key that you get with your account, so that they can talk to each other. So in a nutshell, that's what we got going on. And you know, I don't want to get into too much detail because that's not what we're here for tonight. But if you have any specific questions, Jim, go ahead and ask them again. Hey, Louise and Pete, good to see you guys. Thanks for being here. So, as I said, we're going to be in Sirius here, right around Sirius. We're on Sirius right now, and I used it as kind of my alignment star. In fact, I think I probably need to get a little bit better aligned on it. So, oh no, actually that looks good. Oh, I see, I don't have my screen. There we go. Good, so we're lined up perfectly. So let's take a look at some of the stuff that's in the area here, and there's some really cool stuff. A lot of little open clusters and stuff. There's a little open cluster there, but it's kind of dim. So we'll just kind of poke around and see some of these star clusters that are in the area. Let's just start with this one. Why not? NGC 2345. And because they're star clusters, they're going to be probably fairly bright. Let me, in fact, run my next target 533 so I can set my gain up here so we can hopefully see it without, yeah, it's kind of just a little bitty bit of a cluster there. So let me then, nope, wrong one. That's the wrong one. Just grabbed the wrong script. That was for the other camera. Start imaging 533 is what I want. Okay, that should work a lot better. Yeah, so this looks like just a kind of a simple little cluster in here. Let's see if we have a distance on this. We don't. Stellarium doesn't have a distance on that, but we'll try looking it up in Wikipedia. Let's see if Wikipedia has any more information. Some of these are fairly obscure little things in the NGC catalog that don't have a whole lot of information, but oh yeah, there you go. Kind of a nice little one there. Alright, let's get the histogram kind of adjusted somewhat sensibly. But yeah, you can see there's a nice little cluster in there. And all that's NGC 2345. Let's see what... Let's see what... Come on. Alright, and I can't get my mouse to respond on the other computer. There we go, come on. Boy, it's just been one technological problem after another tonight. Now even my second computer is acting up. Some nights are just like that. Okay, NGC 2345. Do I have that backwards? 2345, that is correct. Huh. No, looks like Wikipedia doesn't even have it at all. Yeah, well, anyway, no biggie. Kind of a nice little star cluster, although I think I have my... Oh, come on. I think I have my colors a little bit whacked out here. Let's put those a little bit better. Yeah, that looks a little bit better. But kind of a nice little cluster. These actually are better off seen in full context, all the surrounding stars. And because we are in Canis Major, you can see there's this, well, I know it's probably faint on your screens, but there is this right here is the Milky Way. Right in here there's a faint light blue haze that's in here that it's probably too light for you to be able to see, but this is basically, we're almost right in an arm of the, well, we are right in an arm of the Milky Way galaxy when we're looking here. So a lot of these clusters here are all star clusters that are in the arm of the Milky Way. So we're going to see a whole lot of very rich star fields behind these objects. There's kind of a nice sparkly one down here too. Here, let me turn the background music on. Maybe it'll calm me down. That's kind of a nice one. The nice thing about the that's about 4 minutes. The nice thing about these star clusters too is you don't have to spend a whole lot of time. You can just kind of zip from one to the other. See, there are some darker patches here which are probably just dust and things that are just little pockets of dark nebulae and dust and things that block some of the stars that are in the Milky Way itself. But get the software out of the way for a minute there, and kind of a nice little cluster. Stretch that a little bit more. Yeah, there we go. Yeah, it's kind of nice. Just a spar, almost kind of like a wedge of stars in there. Alright, there's 5 minutes on that. That's pretty good for that one. Let's see what we've got next. Next target. And go to our planetarium here. Well, let's see what's in here. Let's see what the heck. There's all kinds of, looks like, interesting stuff in here. Let me bring my field of view indicator in, so the red box is what my camera should see. So I'm actually going to go up here and do this one, which is the Seagull Nebula. And we'll just try doing this little nebula right here. See how well we can see that one. I don't see much there yet, but let's try stretching it a little harder. No, not really, but it's such a short hop, I'm going to trust that we're there. And let's see what we can pull in for this little nebula. So, Seagull Nebula IC 2177 doesn't have an NGC number. IC 2177. Let's see what we can see here. IC 2177. Yeah, okay. This one, it looks like Wikipedia is going to have. Region of nebulosity that lies along the border between the constellation Monoceros and Canis Major. Monoceros and Canis Major. It's a hydrogen beta region centered on one bright star. So it's a hydrogen beta region, meaning if I was using a hydrogen beta filter, this would really pop out. It should be reddish in color, which is, the hydrogen is what gives it the red. Yeah, that actually is coming in fairly nicely. Yeah, not bad for a first sub. And then you can see the rest of the brighter region out here that we can see borders it over here. All this brighter region is this stuff over here. So we may just putter around in here for a little bit. But this is the Seagull Nebula. nebula was discovered by Welsh amateur astronomer Isaac Roberts, and was described by him as pretty bright, extremely large, irregularly round, and very diffuse. The name Seagull Nebula is sometimes applied by amateur astronomers to this emission region, although it more properly includes the neighboring regions of star clusters, dust clouds, and reflection nebulae. This latter region includes the open clusters NGC 2335 and NGC 2343. Right, so that's all this region in here. And we'll just kind of putter around in here for a few minutes. But Seagull's head. Okay, doesn't really say how far away it is, but let's get the histogram adjusted here and kind of stretch that a bit so you guys can see it better. Yeah, that looks a lot better. Okay, good. There's about a 30-second delay between what I'm actually doing and what I'm seeing on the live stream that's reflected back to me, so sometimes I have to make an adjustment and then wait a bit to see if it's coming across okay. So Jim, in rereading your question, did I answer your question okay? I mean, your question was talk about setting up for a broadcast, but you may not even have meant specifically the software. I'm trying to think if there's anything else really unique to setting up for a YouTube broadcast other than what I would do for my own normal imaging just by myself. And there really isn't a whole lot of difference. Really just running the OBS and connecting to YouTube to actually run the live stream. Obviously you have to be connected on the internet, so that's, you know, but I am anyway. If I'm out here doing my imaging, I have my laptop anyway, so it's already set up and running and on the internet as well. So yeah, there's the two pieces of software is really all I'm doing that's unique for a live stream versus my own imaging, which made it a little bit of an interesting, an easier, I guess, transition, because I had already been doing imaging for a while. So transitioning into live streaming was just adding the extra step of doing the YouTube broadcasting, which you know, was a learning curve, but it was only one learning curve, as opposed to somebody who's trying to start out and just learn all of it at once. Learn how to do the imaging and learn how to do the live streaming all at the same time. It's not for the faint of heart. Doing this live streaming is an interesting combination of skill sets that is not terribly common. So it's amateur astronomy and all the gear and know-how associated with that, plus you've got to be a computer geek and understand software and computers and how they can control things on the amateur astronomy equipment, and then on top of that, on the broadcasting stuff, and it's a whole lot to it's a whole lot of skill sets to try and bring together to do this. So it's not for the faint of heart. But if you can take it on one piece at a time, do the amateur astronomy for a while, then bring in some imaging, you know, just do visual for a while, and then bring in some imaging and figure out how to use cameras with your laptops, and then of course you've got a whole setup out at your scope anyway. So after you get comfortable with doing imaging using cameras instead of eyepieces, then make the next step and transition into live streaming. But it definitely is an interesting challenge, but it's fun. You know, there are always going to be the rougher nights. Like tonight for me was a pretty rough night with the setup, and I had to do 2 alignments, and then I couldn't get the camera to respond, and then I couldn't get my flats taken because the histogram and sharp cap wouldn't respond, and then it's just, you know, it was one thing after another. So, but that's going to happen no matter what. No matter where you are in life and whether you're live streaming or not. So it's fun, but it's a challenge. So, in this day and age of pandemicness, it's a good way to still reach out and do the part of astronomy that I really most enjoy, which is the outreach, which is showing people the beautiful stuff that's up there. That's just, you know, waiting for them to look themselves if they want, or just keep tuning in and I'll show it to you for you. So, you know, it's I really enjoy this part a lot, so going this next step for me was kind of a natural thing. But it is a challenge some days. Hi Jeff, most of the 6-inch f4 OTAs are back-ordered. Yeah, well, it's not just that, it's most amateur astronomy equipment is back-ordered, and I think almost any hobby-based thing is back-ordered right now because everybody's been stuck at home and whatnot, and so yes, it's all back-ordered. I did see Horizon's 6 inches available. Is that brand any good? I believe Orion's 6-inch is the same thing as what I've got. I think they're all made in the same, basically the same Chinese factory, Guansheng Optics, or GSO. You'll sometimes see that referred to. So I assume it's the same thing. I actually haven't. Oh, look at that! Our mount has disconnected again. All right, where's the? Yep. Yeah, this is another thing. The mount's been really fighting me tonight. Okay. Telescope.com, I believe, is Orion. Yeah. No, I don't want to sign up for your thing. Imaging. Newtonian. Let's see what they've got. 10-inch f3.9, blah 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 blah. 6-inch f4. No, actually, this does look different from. Well, I don't know. It looks like the same focus there, and yeah, actually, you know what? I think this is pretty much the same thing as mine. Yeah, actually, now that I look at it, yes, it's basically the same thing as mine. Which is another GSO. I think it's basically the same thing. They're all pretty much made in the same Chinese factory. And so, yes, I believe it's just as good as mine. But, you know, of course there are lemons in every patch, but it's I would suspect it is the same thing as what I am using. Possibly with a couple little accessory differences or something, like maybe the little finder scope. You know, the little finder scope out here might be slightly different than the one that came with mine, but everything else, the Cinta shoe here, the focuser, everything looks the same. The heads on the spot on the secondary vein, all that looks the same as mine, so I'm pretty sure that's probably the same scope as mine. Although the Orion one, if you notice, is $400. If you go to High Point Scientific and look at their 6-inch in Newtonian astrograph, it's literally what mine is. It's the same thing, and it's $300 new. So you do pay a little bit of a premium going with Orion, and if they actually have it, That's probably why it's still there, because it's much more expensive than anyone else's for the same thing. I don't think they give you anything else. Light 12.7 assembled weight, precise, blah blah blah. Yeah. Heavy duty hinge tube rings, 850 scope, dovetail mounted, but yeah, it's the same thing. It's just $100 more than what most other people sell them for. So that's why, if they have them in stock, that's why they do. But if you go to High Point Scientific, I think their house brand is called Apertura, so it'll be an Apertura 6-inch f4 imaging newt. Mine is actually a TPO, Third Planet Optics. That's just the brand that they stuck on it, but it's all the same Chinese stuff. Well, I think our Seagull Nebula has come out pretty well. That's a pretty cool one. Not sure I see too much of a seagull, but definitely a nice dark lanes in here that are pretty sharp. Different color gradations also in the, so you can see the red. That's really the hydrogen is the red, and the blues and greens tend to be more oxygen. So some of this may be maybe more oxygen, but it also may be just reflecting whiter starlight. And so while this is an emission nebula, where it's actually emitting, it's actually radiating the hydrogen, this may be reflecting more starlight from the stars that are in the cluster itself. But anyway, pure speculation. So I think what I'm going to do now is move a little bit left and see if we can capture some more of this out here. So let's go and go to our next target and just kind of shuffle over just a little bit. Kind of move all this stuff. Oh, nope, wrong way. Wrong way. Let's just kind of let all this stuff move on over here. There we go. Yeah, see, so I want to... Where is our... No, not you either. There you go. Yeah, so if I kind of move this... There's a whole strip. Well, actually, the whole thing is more upright, though, so... Let's bring that back. Come on. Oh, shoot. Pushing the wrong buttons. There we go. Okay, good. Let's see if we can't see some more of this larger piece now. Jim, I'd like to do this for our club. Yeah, a lot of people are doing it for their clubs. Well, I should say a lot of people. Usually in most clubs, if they have enough size, there's at least one sufficiently geeky person that isn't just geeky about astronomy, but also geeky about computers and networking and software and all of the other disciplines it takes to do this. And so those people usually do end up doing like that. I have a good friend who also does live streaming, Gary Hawkins. If you're on Cloudy Nights forums, you know him, and he kind of took that up for the San Diego club, and so he was, geeky enough in all the right ways that he could do that, and so he kind of does their outreach for them, and so that's how their club is staying together, is staying in touch with the folks in their area. I am actually a member of the Las Vegas Astronomical Society, and we do a once-a-month star party on Zoom with a simulcast on Facebook Live, and so I'm a part of that. And so with us, typically at least 5 or 6 of us that are on, anywhere from 4 to 6 people typically, who have scopes and image, and so we kind of take turns in the Zoom broadcast sharing our screens to see whatever we have going on. And so different clubs have responded in different ways. For some people it's for some clubs they have a few people who do this, like the Las Vegas club that I'm a member of, and for other clubs it's only 1 or 2 people who have all the skills necessary to do this kind of stuff. So but yeah, if you can put it together for your club, I'm sure it would be greatly appreciated. And OBS is really the backbone of the whole thing, and because it actually collects all of your signals, the video from your screen and the audio from your microphone, and background music if you want to use background music, and collects all of them and assembles them, and then you get to configure how it goes out and at what frame rates and how much bandwidth you're using when you go out, and you need to balance that against how good your internet connection is, and which for me is a bit of a challenge out here in the middle of the desert. So, although quite frankly I'm stunned that I can broadcast from out here at 720p. So it's I feel quite fortunate that I'm able to do that. Yay LVNet. But yeah, so it's a cool thing if you can do it, but as I said earlier, it's a multi-discipline thing that's not for the faint of heart. Good evening, Al. Nice to see you again. Thanks for stopping by. You may be too zoomed into the Seagull Nebula to see the seagull. Yeah, you could be right. Is this the Celestron PW? Yes. Well, this is CPWI, yes, which has already forced me to reconnect and realign once tonight. But yes, this is the software here from Celestron that allows me to actually control the Celestron mount, the Evolution mount, and allows me to control things, and it does the alignments for me and stuff. So instead of using the hand pad that comes with the scope, you can just use the software if you already have a laptop out by your scope anyway. And for those of us who image, we do. So, and the software is much more powerful and user-friendly than the hand pads are. Although the hand pad, Celestron's hand pads, admittedly are not bad, but they're the software is definitely better. So, but here's 4 minutes on, again, keeping the. Well, you know what? I'm not sure what. I think maybe what the deal is. You guys can correct me if I'm wrong. Maybe the whole thing is the seagull. These are the wings, and this is the head of the seagull up here. Maybe that's what's going on. Maybe it's just the whole thing is the seagull. So we're just kind of doing it in parts here. But it's got some nice, again, a reddish region indicating the hydrogen. And a thick star field indicating that we are looking at right into an arm of the Milky Way. And you can see, well, you may not be able to see it, but from about here to about here is a hazy band indicating the Milky Way, an arm of the Milky Way. That may be too faint for you guys to see it on your screen, but we're going to see a lot of rich star fields tonight because we're going to be right in the thick of that area. I had so much trouble tonight and was working up to the last minute to get on. I didn't even have a chance to get into any of my warm outer layers yet. So here in a few minutes I will probably, after I move the camera again, probably try and catch the bottom part of this, see what cool stuff is down there. I will probably run in and get into some warmer layers. It's actually quite a nice night, though. We're experiencing temperatures this week in the low to mid 70s, so the evenings are pretty pleasant. We're basically in a bit of a tropical flow, equatorial flow, so we're getting warmer temperatures, but that also means that we typically get a lot of cloud flow. So most of the nights this week have been really crapped out. In fact, tomorrow night I was supposed to do an event that I've had planned for 2 weeks for some folks, and as it turns out, it was supposed to be part of actually a dark skies presentation that somebody was giving, and then I was going to do the after event star party. Of course, it was all online, and tomorrow night here is just going to be absolutely crappy. It's going to be just all clouds again. The clouds are going to roll back in. So it's kind of it's nice, comfortable, temperate weather, but it often interferes with the astronomy. So tonight is one of those lucky nights. There, trying to untwist my microphone cord there a little. Oh, thanks, Al, for confirming. The whole thing is the seagull. Cool, cool. Stretch this a little bit more, make it a little brighter for you guys. We'll just give it another minute or two, then move down a bit. The aspect of the color camera seems different than the mono. Yes, okay, Jeff, you were here from one of my last one, where I had the mono camera out, where I had the 183. Yes, the 183 is actually a landscape format, which most astronomy cameras actually are. The 533, with its perfectly square format, is a little bit unusual for an astronomy camera. Most of them tend to be more of a landscape. So yes, good catch. This one is a perfectly square sensor on the 533. Really like the way it gets so much darker around the head of the seagull. It really makes it pop. Whereas the body, or wings, I guess we've decided, are just polluted with glittering stars. I mean, look at that. That is just amazing. How many stars are in that? It's just crazy. Just all the stars in there. So bright. Billions and billions of stars, as Carl Sagan would say. Also, don't have my water out here yet either. I can't even have anything to drink. Well, I'm going to go fix that in here in a sec. So that's pretty cool. I think what we'll do now is we'll move down and see if we can see what's at the bottom part of this. So we'll try and move all of these stars that are currently in there, those brightest stars that are in there, these two here. We'll just try and move those up to the top of the frame. And see if that doesn't bring in the bottom part of the seagull, the bottom part of the wings. Yeah, that's probably pretty good. We should keep a little bit of the head in there. But then we'll just, we'll go with that's probably about right. Alright, we'll see what the bottom part looks like. I don't think there's any other clusters in here on the bottom. Yeah, they're just Just some stars and things. I don't think there's anything really spectacular down there, but definitely some glittery clusters that were up here. So this may be the boring neighborhood, but we'll see. Just want to see how this first one comes in, and then I'll jet inside and get a layer or two on and get my water. So far everything is behaving, knock on wood. It was just a rough start, I guess, to the day. Yeah, more of the seagull as it stretches down here. Some nice 1, 2, 3 bright stars there, which are probably this. Yeah, 1, 2, 3, there they are right there. Those 3 are these 3. So, okay. Just a pretty nebulous region. Alright, I'm going to let this build for a few minutes, and I'll be back. Okay. I'm warmer now. 5 minutes on this. Oh, I got some nice dark lanes in here too. Nice structure in this as well. That's pretty cool. Let's make sure we're doing pretty good there. Pop this a little bit that way. And give it a little bit more of a stretch even. So Jeff asks, was it hard to mount the 6-inch to the Evolution mount? No, not at all. In fact, that's something I didn't really show tonight, did I? Let's bring in my my setup. Sometimes I start off with this. I probably should every time, but so there is my setup there, the 6-inch imaging Newtonian. That's on the Evolution mount that Jeff was just asking about. And no, it installs. You can't see it, but it just has a dovetail bar on the other side and a dovetail clamp. It's a Vixen style dovetail bar that's on the side. It's that's attached to these the tube rings that are here. So on the other side there's a clamp that's just designed to clamp right in there, and it just bolts right up. Very easy to remove and put in place every night. The dovetail clamp is designed to be pretty easy. It's got a big old knob on it, so it's pretty easy to set on and off every night. Basically the Evolution is the bigger, heavier duty big brother of the SE mount, of the Nexstar SE mount. So yes, all of the Celestron mounts, at least all of the computerized ones that I'm aware of, all use Vixen style dovetail clamps. So as long as you have a Vixen style rail or Vixen style bar on it, they all just clamp right in there nice and easy. And there's just basically a big knob bolt that tightens the scope to the mount and then loosens it again, and you take it in when you take them apart. So it's very easy to take on and off the mount, and yet they're held pretty darn rigidly. So anyway, telescope, and so this is an imaging Newtonian, which means basically there's a 6-inch mirror right back here that's concave, so it's dished, and it focuses all the light coming in to one point that's right in here, where there's a smaller angled mirror that bounces the light right up into the eyepiece, or in this case camera, and that's what picks up the images. And this is an AltAz mount, an altitude azimuth mount, so up and sideways is all it really does. It doesn't really track the sky per se. Well, okay, that's not true. It does track the sky, but it can only track it up and over and up and over and up and over, because it's designed. This is designed to mount flat like this, and so in order for it to be able to track the sky smoothly, you have to mount it on its side so that it points directly toward the northern celestial pole, and that's called polar alignment. And that's what this wedge is for that I made just out of cabinet grade plywood. And actually I have a regular commercial wedge that I just got that's going to replace this here probably in the next couple of weeks as soon as I can get around to installing it. And this basically allows the mount to point right at the northern celestial pole, so as it rotates perfectly evenly with the sky, so that longer exposures come out looking fine. They don't have streaked stars and things in them. And so that's what these two things are. And then I just have it mounted on a cinder block pier here, and the cinder blocks are all glued together with construction adhesive, but they're not glued to the cement pad itself. So if I ever do need to move this, two-wheel dolly will move the whole thing. But the blocks are glued to each other with the adhesive, and they're glued to this bottom board, the base board of the wedge, is also glued to the top block. So that's my setup. It's fairly simple. It's inexpensive. I think I paid these scopes here. Well, the Orion one goes for $400. Almost any other vendor sells them for $300. You can get them on the used market for $200, which is what I paid. And the mount itself was $550, I think. And the rest I built myself. So, you know, it doesn't take a fortune to get into this. The cameras that I have are more expensive. The cameras cost as much as the mount and scope combined each. And so that's where I invested my money. But you don't have to start out there. You can start out with just a $200 or $300 camera from the used market, and just kind of, you know, whet your appetite, see what you like doing. There are different types of objects, and different cameras and different scopes specialize in different things. So you know, you can kind of get your feet wet and just figure out what are the kind of things you like to shoot. Maybe you just like shooting galaxies, in which case more of a mono camera is useful. Or maybe you like pretty nebulae, which in case a color camera. Or maybe you like really big things when you need a large sensor, or really small things like galaxies where a small sensor is okay. So you kind of get your feet wet and and figure out what you like doing. All right, so I think I forgot to set my thing here. Okay, so we're kind of in there. So I think we've done Seagull pretty well. Let's go up and do M50. Yeah, the heart-shaped cluster or coil cluster. Let's go up and do that one. Okay, Seagull Nebula. Thank you. You've been fun. I think we've done you pretty well. Let's go see about the heart-shaped cluster. Yeah. There it is. All right. I think we're on there pretty well. Let's see what we can see there. Distance about 3,200 light years away. So not real far away. Take a look at this. Yeah, just a nice little cluster of stars. Of course, in the Milky Way band background, so it's going to be in a pretty lit, rich cluster of stars as well. So Jeff, you said coma question mark, and I'm not sure what that meant. Were you seeing coma in my image, or are you asking me how the coma is in my scope in general? Clarify the question for me a little bit, and maybe I can help you out there. Yeah, there's a nice cluster in a hugely rich star field. That is pretty nice. This is M50, so the 50th item on Charles Messier's list of things that were not comets, so don't pay attention to them. And now the Messier list is one of the most searched lists of things in the entire sky. For those who aren't aware, the Charles Messier was a comet hunter, and he would comb the sky at night for comets. and he kept running into the same things over and over again, these brightish objects, but it turned out they weren't comets, and so he started cataloging all of these bright things in the sky that he could see with his telescope that were not comets. And his original list, I believe, was 101 items or 103 items, I think, that were on his list, the Messier list. And since then, scholars have gone through his notes and realized that he actually discovered several more, and so the Messier list is now considered 110 objects long. And in any event, what he ended up finding was basically the 110 of the most spectacular things in the sky to see. So it's a very popular list for amateur astronomers to take a look at. Like this bejeweled wonder here. Isn't that pretty? Lots of stars. Just in a tight little clump. With a starry background. And what have they got here? Large brightness ranger cluster is mounted with 50 to 100 stars, they're saying, in this cluster here. So okay, that's what your question meant. Does a 6-inch need any correction? It depends on the size of the sensor. The answer is yes if you're using, certainly if you're using bigger than a 1-inch sensor. From my 183 and the 533 that I currently have in, if I don't have any coma corrector, and I ran it for a while without a coma corrector, you will have in the very outer corners some mushy stars, some slightly streaked stars, pin-cushion stars, where they're just slightly streaked to the corners. So there will be a little bit. So even with the 1-inch sensor, you can get away without it. I am actually running a Beta MPCC, which is not a real high-end coma corrector. It's not a multi-element coma corrector, and it's the minor amount of coma correction that it does is good enough for the cameras that I use, because I'm limited to pretty much to what's considered a 1-inch sensor. If I was going with a bigger sensor than that, I would probably need to get a real, 3 or 4 element, a real coma corrector. So to answer your question, for a 1-inch sensor or smaller, no, you certainly don't need correction. I run it because it just makes the outer stars look better, so it's a bit more appealing. But no, it's not required. If you do have a 4/3 inch or a full frame sensor, you'll definitely need one though, yes. So it depends more on the camera than the scope itself. But when you start getting fast optics, much faster than about f6 or so, you're going to get coma on larger sensors. And so this being an f4 is nice and fast, but it's that speed does come at a little bit of a price. It does have its optical... no, I didn't want to do that. Not that one. Come on, go away. I wanted to do... not that one. This one. Okay, there goes M50. Alright, let's start working our way back. Now, what is this? This is a reflection nebula? Well, let's see if we can see anything. Let's see if we can see anything in there. Again, this was a pretty short jump, so I think I'm going to just move it a titch in. And let's see, let's run a couple of subs here and see if we can pull anything in. Pull anything in on that. But it looks to me like it's one that they don't even really have. Yeah, they don't have. Stellarium doesn't have an image of this, so, And M50 that we just saw is just outside of the frame, but at mag 9 and surface brightness of 11 we should be able to see something. So we'll see what we can see. Then we'll figure out where we're going to go from there. Probably just work our way back down. We're starting to get a little bit off our canine friend here. Probably actually drop to something that's a bit lower before it starts dropping us. Yeah, see, we haven't hit 180 degrees yet, so we're not quite. It hasn't transited yet, but it's getting close. And we'll maybe go do some of these lower ones down here. Well, there's our first sub. Okay, so I see what they're talking about right in here. There's nebulosity surrounding this little star cluster here. And we'll have to pull in a few more sub-exposures to make that less noisy. But it looks like there's just a little bitty... What does it say? Size... Yeah, so it's 3 arc minutes in size. So it's very small. But we'll run a few subs on it. Certainly won't be big and spectacular like our Seagull was, but I think a few sub-exposures will be in order. Whoops. Yeah, there we go. Starting to... Let's brighten this up a little. Maybe calm it down a little bit till we get a few more in. Let me check the color balance too. Yeah, just kind of a little guy. Just a little bit of nebulosity around these little stars. Won't spend much more, another minute or two on it, but it definitely has some nice fuzzy glow around those stars. Oh, I wonder if it... nah, LBN doesn't have an NGC number, which means it probably doesn't have any more information on it than... Probably not much known about it. Is there a distance? No, there isn't even a distance. Well, that's probably good enough for that. Such a little guy. Probably not much more we're going to see there. So, let's see where we go next. I think this is just a star, isn't it? Yeah, it's a star. Alright. Let's work our way back down. Let's go down to the bottom here. See what... don't really want to get too far below 25 degrees. And let's see how this one comes in. 2354. No, that's targeted a galaxy. That's not what I wanted. I wanted you. We'll get the galaxy too, but we'll get that all in the same shot. But for now, let's get the cluster. I think this might be a fairly loose, no noticeable concentration of stars, medium brightness range of cluster members. Again, 50 to 100 stars. I think it may just be this here. This bright star and this bright star may be these two. Not sure. Oh, you know what? I've got the wrong sensor in here. Boink. There. I've got the 183 still selected. So, yeah. Actually, I think it's this one, because this one, see how much, this is a reddish star? So I think this is a reddish star, so I think that's these two here. So I think we're pretty much on target. So let's go ahead and do this, and then we'll see if we can also see the galaxy as well. NGC 2354. Let's see what it says in here. NGC 2354. Open cluster, Canis Major, 2 degrees southwest, blah blah blah. About 15 member stars are visible through binoculars. Okay. So, not much of a write-up there, barely enough to acknowledge that it's there. So, we'll see if we can see not only that, but apparently there's a galaxy in here as well. Woo! That's a bit blown out. Let's try calming that down a little bit. See if we can. Well, it seems to me the galaxy was not too far off it. This could even be it over here. Don't see anything yet. All look like stars to me so far. We'll see what happens when we pull a few more subs in. Yet again, another section of sky just polluted with stars. Look at them all. Almost looks like some fuzziness or patchiness up here that could be some dark nebulae up here, partially obscuring or fuzzing out some of the stars. But this definitely is the patch here. This brighter patch is what you can definitely see in binoculars. But then when you put a camera on it, you can see there's a whole lot more members than just the brightest 12 or 15 or so that you can see through binocs. Wonder where that galaxy was. Ooh, way up there, huh? Well, that would put it kind of at the top of this image. It should be within this view then, if that's true. Yeah, that's pretty much centered in there. This is pretty well centered. So I would think it would be in here somewhere. But I'm not seeing it. Pretty cool little cluster though. But we don't need to spend a lot of time on that one. Let's see who's next. Where are we going next? So where am I at? I'm at 25 degrees. Well, let's do a couple actual galaxies. How is my elevation? It's not too bad. Is this one bright? Not really. Alright. Let's see what this one will do. Galaxy, huh? Well, let's give it a shot. Let's give it a shot. Okay, to do that, I needed to do this first. Boy, am I going to be able to see it. Oh yeah, right there. Right there. Okay, good. Let me bring it into the view a bit better. And kind of center it up a little bit better. Yeah, that's perfect. Alright. Perfect. Right about there. Okay, let me synchronize this so that we are synced up here. There you go. And now let's start a sequence on this. See how much of this we can pick up. Looks like it's just gonna be a little guy. But that's how the vast majority of galaxies show up anyway. They're not very big, because most of them are really, really distant. This one's 100 million light years away. So, not exactly one of our neighbors, but $100 million light years in galactic terms isn't all that much either, so generally a galaxy is within about 20 or 30 million light years away are considered kind of our more local folks. When they get to 100 or 2, they're more of the distant variety. When they get more distant than that, the only ones we can see are something really big and special and spectacular. Yeah, we got a little bit of a, looks like even a little bit of a disk here. We'll have to see as that comes in how that improves. That's pretty nice. Yeah, it does definitely look a little like a little bit of a disk there. Let's see what 2280. NGC 2280. Spiral galaxy located in Canis Major. It's located at a distance of 75 million light years, they're saying in Wikipedia, which given its apparent dimensions means that it is about 135,000 light years across. So it's about 30% larger than the Milky Way, which is about 100,000 light years. It was discovered by John Herschel on February 1st, 1835. One supernova has been discovered in it. In 2001, a Type 2 supernova discovered by the Beijing Astronomical Observatory Supernova Survey on September 15, 2001. It had a peak magnitude of 17.4. Wow. Well, just the fact that we can see a supernova from 100 or 75 or 80 or however lots and lots of millions of light years away is shows how massive they are. Yeah, you can see some of the spirally arms out here. Oh, and I forgot to do something, didn't I? Yes, I forgot to throw my enhancements in here. Shoot, forgot this stuff. It helps sharpen things up a lot. Also another little fuzzy patch out here that's not a star. It may very well be a galaxy. Just a really faint one here. Okay, so this trail of bright stars here above it would be this. So if this were a galaxy, it would be something in about here. Something in about here. Let me try turning off my filters and see if any of the catalogs pull something in there. Yeah. 2 of them actually. 2 PGCs. Second one in here somewhere too. Not just 1, but 2. Definitely see the fuzzy patch there. I'm not sure I'm seeing the second one. Definitely see one though. That's something that was just too fuzzy to not be noticed. There's something that may be blobby here, but it's hard to tell, it's so faint. And with the color camera, it's not the ideal galaxy camera anyway, so. And then put those back. But yeah, there's apparently a couple of galaxies in there, which is kind of cool. And I think there is another one. Maybe that is it down there. Well, this is kind of fun. You start to see the arms just a little bit in there. Push the stretch just a little bit more. Got a pretty good reach of stars spiraling off it. Give it one more minute. That'll put us to 10 minutes. Then we'll move on to the next thing. In fact, let's figure out what we're doing next, huh? I guess we could try going over to you. And we'll work our way up. 12. That'll be a very faint one. If I had the mono camera in, I might try that one, but how big is it? 4 and 3. That's another really small one. So 3 and 1, 4 and 3. Actually, it's substantially bigger than the one we're already doing. So you know what? Okay, we'll try it. It's fainter, but larger. We'll give it a shot. So there's 10 minutes. Yeah, and this one actually is starting to come in a little bit better. Almost looks like some tails coming off it there. But this one definitely got some spiral action happening. Spiral arms on there. Cool. 100 million light years away. There it is, just a bright puff of light in amongst all the stars. Alright, let's go see what the other one looks like. Dimmer but larger. Next target. Alright. Oh, we're not responding. Gee, guess who is disconnected again? Gotcha. Okay. Go. Yeah, I'm gonna change that. Yeah, right dead center in the middle, looks like right there. I think that's you. Okay. Let's start imaging on it. While we're doing that, I'm going to change this. I'm going to edit this sequence script because so I want to edit the 533 next image, next target 533, because I want to put this mid-tone. I want to put it, well, not 0. 0 might be a little bit too much. 0.05. Let's try that. Stretch the heck out of it. Save. Because I'm finding even with edit point 2, it's not nearly close enough. Oh yeah, look at that. It's a good old little circle. Oh, actually, I was on this the other night, I think. I think we did this the other night, if I'm not mistaken. I think this. I was out here by myself the other night, just working on some other things, and I found this. I had the mono camera at the time, and thought this was kind of a neat thing. It's kind of a barred galaxy, so you can see there's sticking off the sides. There's a bar of stars coming off each side, and yet it's got a complete halo of stars all the way around it. See what happens when the second sub comes in here. Just any second now, the second sub's going to pop in, boink, the background goes darker. Yeah, let me take a, what is this? This is 2217. Let's NGC 2217. Is a nearly face-on lenticular galaxy of about 100,000 light-years across, so about the same size as our Milky Way, that lies roughly 65 million light-years from Earth in Canis Major. It's part of the NG 2217 group of galaxies. It's classified as a barred spiral. A notable feature is the swirling shape of this galaxy. In its very concentrated central region, we can see a distinctive, very luminous bar of stars within an oval ring. Further out, a set of tightly wound spiral arms almost form a circular ring around the galaxy. Central bars play an important role in the development of a galaxy. They can, for example, funnel gas toward the center of the galaxy, helping to feed a central black hole, or to form new stars. So there's actually circles within circles on this one. Well, we'll see. We'll see. up out of the way here. Okay. There. Track what's going on there. So very interesting. Yeah, so you can even see already there you can see the core and the bar. Then you can see there is a circle here. Distinct circle inside, a ring on the inside, and then there's a whole ring on the outside as well. Very interesting looking galaxy. And it's about 100,000 light years across, so about the same size as our Milky Way. But it's not a regular spiral galaxy like our Milky Way is. It's more of a lenticular, which means it doesn't have tightly, sharply defined arms. It's more vague, spirally shapes. But if you look at the Hubble image of this, this outer ring actually has distinct spiral swirls in it, which you can't really tell with this camera. Perhaps if I had the mono in, but even that, maybe not. You'd probably have to have some pretty spectacular seeing to be able to pick up that kind of detail. Probably even more magnification than I've got with this little system. I am pretty limited on my my levels of magnification, but you can definitely see the bar and the two circles, the inner circle and the outer circle. Kind of a cool galaxy. Very interesting. coming up on 9 minutes. I'll give it one more minute to get to the magic 10. We could probably go a while on this one. But I find after about 10 minutes, the bang for the buck goes down. So, unless it's something fairly big and bright and detailed, going more than about 10 or 12 minutes doesn't really buy much. So, cool. There's 10 minutes. That's a very interesting looking galaxy. It would be something that would be even more interesting to do with the, whoops, wrong way, with the mono. That's pretty cool. Alright, next target. That really stretches the heck out of that, which is nice. Cool, I like that change. Alright, I think now we're gonna start heading back upward here. Interacting galaxy. Another really small one. Well, let's do a couple of star clusters here. CR121. And let's try that one. Alright. No noticeable concentrated large brightness range of cluster members. Poor cluster with less than 50 stars. Well, that's underwhelming. It's kind of a nice... Well, look, this seems to be an area of nebulosity up here. So let's just... An interesting colored star here, so... Let's see if... Just kind of take this whole region in. Yeah, so there's that nice, interesting colored star. So let's just take this whole region in and see if we can see any of that nebulosity. See how much of this we can pick up. We get this little quote-unquote cluster, and then the red star. Constellation, parallel spectral type, 2IAB. Don't know much about spectral types of stars. Definitely some nebulosity out here. Is that, yeah. Okay, yeah, that's the brighter part of this nebulosity here. Is, what we're seeing right here, just kind of a faint little trace of it out here. So we'll see as we pull in some more sub-exposures what we can see of that. Get cluster and an interesting star and some nebulosity all in one shot. Let's see where our histogram peak is. It's actually not too bad. Let me try backing off just a titch. Make it a little less noisy. But that may have made it a little too dark for you. We'll see. That's about right. Let it get a couple of subs on and get a few on, and then we'll re-stretch it again. See if we can pick up some more of that nebulosity in this big region. This actually looks like the remnants of a supernova. The Dolphin. Now, okay, so this is a Dolphin Head Nebula. Okay. I don't know how much we're going to be able to see, but just so many stars in here. The planetarium doesn't show all the stars that are here because there's only a limit to its catalog. But we certainly have a really rich star field that we get to see with the camera. They're all there. We got a few of those in. Let's re-stretch again, bring some of that color back. Let's see how. Yeah, that nebula is definitely very faint. And it's on such a rich star field that, I mean, I don't know, this obviously is some sort of image they got for it, but how did they get that image without all these background stars? They must have gotten it with, I don't know, some sort of filtering, but because I just get it. I mean, you can just barely see it. It must be some sort of filtering that they use to get that image. Because full spectrum, we just get so many stars. It's just again, just an image polluted with stars. Just zillions of them. So it's kind of hard to see. Yeah, I guess they post-process and scrub the stars or something. Because man, this is in such a rich star field that I don't know how the heck they get such a cleaned up image of this thing. Yeah, that's my suspicion too, is that the oxygen is just, they're using a specific filter for it. full spectrum, it's definitely a lot of stars, including this really bright one. Well, what are we going to see next? That's kind of interesting. This is actually one of the stars of Canis Major. This star that is in the center of... So this star right here is actually one of the stars that makes up the constellation of Canis Major. The dog. Let's see, 2354. Get that one. What do we got here? A reflection nebula. How big is it? Size 5 by 3. Yeah, not that small. And no noticeable concentration. There's a couple of NGCs up here. We can try doing those. Come back to M41. We'll try doing those NGCs next. You can definitely see it's, you know, there's I basically catch the brightest edge. You know, I catch the brightest edge of it, but you know, this clearly is the brightest edge. The rest of it is a lot fainter, and that's about all I can see in this image. It's just that bright edge. Can't really make out much of the rest of it at all. Must have to take those filters. Use those filters. Alright. Let's head over and do a couple of these NGCs over here. Charlie Brown's Christmas Tree. Alright. That's it, upside down there. Yep. A little upside down. Yep, there it is right there. Let me try putting it in the center of the frame a little bit better. So center that up. It's about right. And we'll synchronize that. Synchronize the scope on that. And let's pull in a few subs on that and see how we do. Charlie Brown's Christmas Tree. Of course, another thing I could try to do, since we're doing star clusters, is I could reduce the exposure time. That would kind of reduce the star field clutter in the background a bit. But with star clusters, you really don't need quite as much time. I could probably even cut it down to 16 seconds or so. But I don't know. Kind of in love with my 60-second exposures. For most things, it works best. Boom! Look at all those stars. Good griefus. Look at all those stars. And just the, I guess, the spindly little Christmas tree in here. Two little branches. Almost looks like rabbit ears on the TV or something. Huh. Kind of a neat little cluster, I guess. Not much to it, but does make a little bit of a shape. Yeah, we'll pull in one more and then we'll move on. Almost look like I'm getting some nebulosity down in here. Sort of color in there. Huh. Oh, I got a streaked. The star's looking all streaked now. I got a sub-exposure that was a little streaked there. That's okay. Let's move on to the next one anyway. Let's go on to the next one here. Yeah. 2383. Alright, another little cluster here. See what this looks like. Yeah, sort of this cluster in here. In fact, I think I'm going to... Let's try... So this would mean editing, if I want to reduce then I need to go to 16 seconds here. So let's go to 16 seconds here, and then I will load. And then I will load the 16-second dark. In fact, let's just restart this. Start imaging. 16 seconds, very good. And then I will load the dark for the 16-second dark. 16 second for -10, right? Yeah, yes. Okay, this will be the right dark. Let's in fact, yeah, restart that, and we'll just start doing 16 seconds for these star clusters, because 60 seconds really is kind of overdoing it for star clusters. Yeah, there we go. This will have us pulling in sub-exposures a lot more rapidly. Definitely a pretty little cluster, though. I hate it when I hit that cord. Not sure it reduced the star field terribly much, though. There's still a ton of stars in there, but they are less bloated. With the lower exposure time, the pixels don't get quite so saturated or bloated. Got a pretty little cluster. Definitely see some different colored stars too. Let's check the color belt. Ah, come on. Check the color balance here. Yeah, color balance was off a little. Okay, definitely some orangish, yellowish stars in here, and some of the younger, whiter, bluer ones. And pockmarked different spots. Zillions of stars, though. Man, look at them all. That's just one small pinpoint section of an arm of our Milky Way galaxy, and the density of stars in there. And yet all those stars are so far away that they're actually quite a lot of distance between each one of them. Galaxies look like they're these big bright objects, but they're mostly space. Which is why when galaxies collide, entire galaxies collide, and it's the number of stars in solar systems that actually physically collide is virtually nil, because there's so much space between all of the stars. The only reason that galaxies tear each other apart when they collide is because their gravity wells interact with each other and pull each other apart. It's really kind of a wild thing. There are models out there you can see of what they think it's going to look like when the Andromeda galaxy and our galaxy collide in a few billion years. Well, that's a kind of a pretty one. Alright, let's do the next one. 2421. Alright. Oh, looks like we have disconnected again. Yes, we have. Yeah, in fact, our network has even disconnected again. So let's reconnect this. Alright, and now we'll try reconnecting this. Come on. Hey, why do you keep going away? Come on. This is not good. This problem is hopefully going to be going away soon, because I'm not going to be connecting wirelessly anymore. Come on. Does not look like it's going to reconnect this time, which means I will... The only solution for that is that I have to realign. Yeah, this night has definitely not been fun. Come on. Nope, it looks like it's just not going to reconnect. It's struggling even to stay. The network for some reason keeps going down as well. Yep, well, this may just be the end of it right here. Shoot. Oh well. Let's see if the network came back up. No, unidentified. Yep, and that means, when I see that problem, that means the entire laptop has to be rebooted. So, I think I'm just going to call it quits right here a little bit early. So, well, we saw a good number of things. Sorry that it didn't. Yeah, see, all my software is now locked up too. I can't even do anything. So, been going just about 2 hours, so didn't see certainly everything that I intended to see tonight, but saw most of the good stuff. So, but the technological woes just continue. So I think I'm just going to call it. Oh boy, CPWI also went away. I think we're just going to call it quits. So, anyway, thanks everyone for joining, and sorry we had a bit of a frustrating technological night tonight. Got a couple decent hours in, so it wasn't too bad while it lasted, but it was a very rough start, and now the end is upon us. So the technology is telling me forget it. So anyway, I think I'm going to call it quits for the night. Thanks everybody for joining, and right now the weather forecast is looking like possibly even Friday night. May be able to get out here and do something else. So may see you in a couple of nights, but in any event, I will see you all later. Thanks for being here. Good night.